All right. Are we ready?
Yeah, dude. Week 3. Let's do it.
Week 3, ClojureScript?
ClojureScript.
All right, cool. Let's do
Get
it.
into it.
All right, so when you do a ClojureScript project starts the exact same way as a Clojure project, which is just line new, right? So I don't know what you want to call this project. We'll just call it CLJS test. I don't know. That's a bad name for it. All right, sorry, hold on.
So line is just the
Line new.
is like the build tool for Clojure.
Yeah, it'd be like doing Rails new or something.
Yeah,
It just
or
basically
npm
npm init. It templates out a Clojure project the same way npm init would template out a JavaScript project.
Yep.
So, line new hello world, which will be the name of our ClojureScript project. So this creates a bunch of artifacts. I'll open them all. So we can cd into hello world. Let's do a tmux thing. Tmux new session -n.
Dope.
Get some tabs on tabs. Okay. So if we just open, oh yeah, that thing. It's really weird why it randomly does that now. But okay, so file open.
Where it like doesn't open your like folder for your folder for you. Is that what you're talking about?
Yeah, like it's just like can't find the executable. But
Yeah,
anyway,
it's weird.
so we've got this stuff on the left-hand side, right? So if you've never seen a Clojure project before, project.clj, this is basically like your package JSON. It defines the dependencies of the project, some metadata and information, like the version number. So if you deploy it as like a publicly accessible library, everything will be accessible, right? Then it gives you this file called helloworld.core. So Clojure is built around namespaces. This is something that's very different than JavaScript, where each, like the core level of abstraction isn't a file so much as it's a namespace.
Yeah.
You could have multiple namespaces in a file. And then what you do is in other files, you require other namespaces as opposed to requiring other files.
And so then in the namespace,
Yeah.
is that just like like a folder, or how do you make sure that like if you have two files that you want to be in the same namespace, how do you make them like be in, or is that not possible?
Well, basically a namespace, it would be like kind of like if you had a bunch of libraries in JavaScript, the libraries aren't accessible at a global level. They're accessible under some namespace that you imported in, right?
Yep.
So I guess it's kind of similar like that. You define a bunch of functions against a namespace, and then you import them into your project.
Right.
And a library will just expose namespaces to you. So you can require certain namespaces from that library when you want to use it.
Totally.
So this is a hello world in Clojure. So if I just did line run, that'll actually run the Clojure file. And it'll look for a function called main.
Okay.
So this says there's no main namespace defined in project CLJ. So in my project CLJ, I think you can just do something like this, where it's like main,
You just tell it.
and you give it the namespace. So helloworld.core. And I'm not sure if you need to put an apostrophe on it or not. I'm just going to leave it like that and see what happens. This is fascinating stuff.
Fascinating.
Oh, so yeah, then in here you'd need something called like, I think main, So like some function called main that takes, this would be like an argument into the function. We don't need to do that. It needs to be like that. But I think this will actually work though. This will run like hello world.
It's just gonna print it out to the. Okay.
Yeah,
Yep,
exactly.
sweet.
So that's I made one namespace in a file that ends in .clj, right? And this is Clojure code. So Clojure is a language. It's a syntax for writing programs.
Yep.
And what people think of as Clojure traditionally is a compiler that compiles that Clojure syntax into the JVM bytecode and runs on an application server.
Okay.
So like you'll make a EC2 instance in the cloud, you'll install the JVM, you'll write a program in Clojure, and then you'll compile it into Java bytecode and run it the same way you'd run a Java program.
Gotcha.
So it's just an easier way to write Java. That's like one way to think about it.
Yeah, I've heard that there's like the whole Java interop kind of deal.
Yeah.
So it is just built on top of Java.
It's a Java library. Literally, it's a Java library.
Right.
And it gives you a syntax for writing programs.
Yeah.
Where it gets interesting is that in 2011, I think, Clojure, I think, was started in 2007, something like that. But in 2011, they released this library called ClojureScript. And what that did is it took the exact same Clojure syntax that you were already writing your code in, and it gave it a compiler that compiles into JavaScript. So when people talk about ClojureScript, it's not really a different language than Clojure. Clojure is a Java library, and it's really a syntax for writing programs. ClojureScript is the compiler that goes from that Clojure syntax to JavaScript. But there's a lot of interesting things in that ecosystem that are like very different than just like the traditional JavaScript ecosystem.
So you're saying the word Clojure is kind of like overloaded in that it is the language, but originally it was also like the compiler.
Yeah,
right?
exactly.
Okay.
And ClojureScript is really the JavaScript compiler. So
do you still have access to like the Java functions when you're writing ClojureScript? Okay.
But you can access. But so you'll see the way that the programs evolve is that when you write a ClojureScript program, you can write ClojureScript and Clojure in the same file. So you can have one file that can compile to Java and JavaScript. And there's a special syntax that you write your files in so that it knows, hey, if I'm running in a JavaScript environment, like use this kind of function. And if you're running on a Java host, use this kind of function.
Interesting.
So you can make programs that are portable across ecosystems.
Right.
And by the way, this is how programs will be written in the future. Like you will be able to write universal programs like this in whatever language you want, and then have it just port to host systems anywhere else.
You just have that view because you just feel like that because like React Native is kind of forging the way for that, or is that?
Well, it seems like if you follow like the WebAssembly project at all, it seems like people are going to start writing programs that can compile into this WebAssembly code, and anything can. You can compile Ruby into WebAssembly, or you can compile Python into WebAssembly. So you'll be able to write UIs and kind of and like use the browser as a UI for any programming language. Yeah.
That sounds really cool.
So ClojureScript's a little ahead of the curve here because it gets to JavaScript, but what's coming in the future is that any language is going to get to this WebAssembly thing, and any language will be able to do what you can do in ClojureScript. So this is, in some sense, a glimpse of where programming's going.
And is WebAssembly like, does that exist now? Or is that,
I think
what your browser really understands?
WebAssembly. Man, reading about this stuff is interesting because it's really new and it's really cutting edge. And I don't understand a lot of the tech of it, but like some really smart people will be tweeting like, yo, this is a big deal. Like Google, I've Microsoft, Mozilla, and a few other people have been secretly toiling away, and what they've been working on is no small thing. Yeah, so like you should definitely like read up on this.
Interesting.
But yeah, basically like the workflow that you have in ClojureScript is the workflow that we're going to have for a lot of different things.
Interesting. Okay.
So anyway, this is a Clojure file. I just ran it after many tries by just doing line run.
Right.
So kind of the key thing, and so Clojure is on version 1.8 something I think right now, but in 1.7 they released a change to the code that let you write files instead of with the .clj extension with a .cljc extension. So by putting a .cljc extension on any file, you're suddenly able to read that exact same file in ClojureScript. So basically, I'll write all my files that when I write a Clojure program in .cljc, unless like you're writing like a web server or something.
And that's just so that it can be used in a Java world or in a Java.
Yeah, exactly. So it's completely independent of the host that it's running on.
Right.
So anyway, I think if we can get a hello world running in the browser, we'll be in pretty good shape. The idea is that we can build a UI in Clojure, compile it into a JavaScript file, and just have like an index.html on a Python web server or whatever.
Okay.
I don't normally do that, which is why I'm like interested to see if this is going to work or not. But okay, anyway, so ClojureScript is just it's just a Clojure library. So I can go to project CLJ. We need to use Clojure 1.7. I don't know why that's on 1.6, and then you can just include the ClojureScript library, right?
Okay.
And then we're going to include a couple other things. I want to include Reagent also.
Okay.
I didn't do anything else, and we'll get to that in a sec. But anyway, so just normally if you do line deps, that'll install any external dependency. That's like doing bundle in like Bundler or something.
That'd be bundle in like Ruby world or
I already have all these installed, so it doesn't do anything. Now, okay, so once you have ClojureScript installed, you have access to this function called line cljs build. And so line is short for line engine, which is the Clojure build tool, but it does a lot of the things you would normally use Webpack for if you're writing a JavaScript app.
Yep.
So line cljs build is like a build step that will look in your project CLJ for the cljs build function, and it'll compile your Clojure code into JavaScript based on your definition.
Ah, cool. cool. So we need to give it like a config.
Yeah, so like normally I have something like this, right?
Sweet.
So it's like CLJS build. And basically, so it looks like you have this thing called builds, which is, yeah, and I'm going to...
We only need one. We probably don't need the production one. Or we probably don't need the dev one of those.
We don't need the production one.
Okay.
But anyway, so it has a key called builds, which is an array of different configurations. And then you give it an ID, so you can have multiple builds. Normally you'll have dev and production,
right.
like at the very least, and production is super minified. Whereas dev has white space and you can read the output.
Yep.
So source paths, what this is going to do is it's going to say where in your project should I look for ClojureScript files,
yep.
right? So by default, it's source/CLJS. So you'll see people when they write Clojure projects, make a folder for CLJ, make a folder for CLJS. I kind of think this is weird because I like writing libraries that work on both systems. So I'm pretty cool just doing source for this, like, and just any file.
Yep.
Like, look in this source directory. I guess that's probably more efficient if you actually have things that are Clojure specific and you don't even want it to try and reload that
right.
when it changes. But for now, we can just do anything in the source directory. Figwheel is a library that I will show you for sure, but we can comment this out for now. Figwheel is the library that you use for live reloading of UI state as we get into it. Like, it's really cool. It's really hard to use ClojureScript without Figwheel, I think it's like a necessary tool.
Interesting.
Optimizations. So that gets into a little bit about how the ClojureScript compiler works, but there's a Java library created by Google called Google Clojure, spelled like this. It's one of the most unfortunate naming collisions ever.
Yeah, it seems pretty bad, yeah.
Because this has nothing to do with Clojure, the programming language. But the Google Clojure compiler is a JavaScript to JavaScript compiler that does code optimizations and performance optimizations.
Yeah, I've heard of that.
So basically you can't give any JavaScript file to the Google Clojure compiler. You have to give a very specific kind of JavaScript file,
right.
which is optimized to go into the Google Clojure compiler, and then it comes out incredibly optimized.
So does that mean that you write your JavaScript or your ClojureScript in a certain way to make sure that it conforms to that?
By default, any ClojureScript code will be compiled. So ClojureScript code gets compiled into JavaScript code that's meant to target the Clojure compiler.
Gotcha.
And then the Clojure compiler can optimize it down. So when you're setting up your compiler settings for your dev build, you don't even need to use the Google Clojure compiler at all. You can just like make JavaScript code.
Right.
But when you're going for production, you'll actually put it through all these things that do code minification.
Right.
They call it dead code elimination. So if you import a library and you only use 2 functions from it, it'll strip out everything else into the bundle.
Right.
And it'll, like minify all the variables and all this kind of stuff. So normally optimization's none means it's not going to do any of that. It's
so
just
it'll
going to
just leave it with white space.
Yeah,
and
exactly.
Long variable names. And
exactly. But optimization's advanced. This'll make it as minimal as possible.
And that'll use the Google Clojure compiler.
The Google Clojure compiler, right. Output 2. So this is what directory you want it to go to. So, we have this resources directory.
Yeah, let's use that.
Okay, so we can make public JavaScripts.
Yep.
And I guess we would put like CSS in this directory as well. So we have resources public JavaScripts, dev.js. I think that's a fine name. And then output dir is like what actually I'm not even really sure what the output 2 and output directory difference is. I guess we'll see.
Yeah.
But I know that you need both of these.
Okay.
And then pretty print and source map. Nice. These are just again like things that we're not optimizing. Like
right.
You would turn pretty printing into false, and you'd turn source maps off if you're like compiling for production. Right. But we can leave this the way it is. And I believe that now, so we have this namespace, we have this main function.
So if we just
and all it does is print line, right?
Will just make it console log.
Right, exactly. So if I wanted, so again, this is just Clojure, right? It's a CLJC file.
Right.
We have no JavaScript. We can't run anything.
Right.
But if I run this function line CLJS build, this is how I tell my project that I want to compile whatever Clojure code you have and output a JavaScript file according to those settings that we defined. So line CLJS build, and then you give it the name of the build target. So we gave this the ID dev, right? So you can say which build you want to do. So I'll do line CLJS build dev, and I'll do once. So if you do like auto, then that would be like webpack-w,
Right.
where it's watching for any kind of changes. If you just do once, it'll just run the script once. It'll output the JavaScript and exit. So we can see that.
But so what's the difference? So if you just did line CLJS build,
The line CLJS build, you need to add that. So basically, if you want to run line CLJS build, you need to add the line CLJS build plugin, right? So that's probably something. Yeah, this thing that says plugins line CLJS build.
Yep.
Yeah, so that needed to be added so that I can do that. So I guess that's not native to Clojure. And again, this is the seminal issue with Clojure is all this like
Right.
configuration stuff. Like there's no like Rails like framework that has it. So you're constantly running around. So let me comment out this Figwheel thing also. So let's just assume we just have line CLJS build, and let's run that. So if I think it's once dev line CLJS build once dev, right?
what happens? Can you just leave the once out? If you just did line CLJS build dev.
I don't know. Let's see. So okay, so this ran. If I just did line CLJS build dev, let's see what happens.
Right.
I actually don't know what that would do.
And you're saying there's some other option that you can add to make it watch.
Yeah, so it thought that was it. So you have once, you have
Okay.
auto, you have test, REPL listen, REPL launch, REPL rhino, sample.
So why do you need? My question is, why do you need Figwheel when you can just use auto right there?
Well, right. So line CLJS build auto will watch your ClojureScript files.
Yeah.
Whenever there's a change, it'll rebuild the JavaScript file.
Right.
And then if you refresh the browser, you have your new changes.
Yeah.
What Figwheel will do is it will do kind of a delta on what the changes are in your file versus what's currently on the screen, and it'll inject the delta in. So you don't need to
So it's way
reload.
faster.
So you don't need to reload your screen first off.
Oh.
Second off, you can preserve your application state of your UI. So basically, and this gets incredible, which is why all this, turmoil is actually worth it in the end, is that you can have a stateful UI, you can build some sort of state, and you can literally just change an event handler, or you can change the way part of that state is rendered and just
Right, but
inject
leave
it
the
in,
state
and the state
the same.
stays the same as it gets modified.
That's
So
pretty amazing.
yeah.
And there's definitely stuff going on like that in like the JavaScript world as well. Like
Yeah.
with, like the whole Redux. Like if you're programming like a Redux style, where your state is all the way like decoupled from your UI, then you can like do a lot of like the hot reloading type stuff like that, which is cool.
Yeah, no, that sounds
It's
awesome.
it's kind of the same thing in Clojure or ClojureScript.
Yeah, exactly.
Like
And I think that this pioneered that. I actually believe this
Right,
is like
sure.
the first implementation before you could even do it in JavaScript.
Right.
So
And does I guess the functional like style that ClojureScript or Clojure has is going to be really like useful
Yep.
out front, right? So like the data
and it's not just Clojure being functional, it's
Yeah.
like being based on Lisp. Like I think that building UIs is like the great use case of Lisp. I mean, I know a lot of people use it for artificial intelligence kind of stuff, but when you're building like UIs in it, like it really shines, I feel like. So
because it kind of like guides you into having your state be all like in one place instead of like scattered throughout,
yeah,
Like
definitely.
if you're in more of like an imperative kind of style, you have like random state just like dispersed in all these like random places.
Well, it's stored within an object, basically, as opposed to, just being completely global to the application
Right.
and have different components, like, read off of it. So, yeah, it is really natural. But, okay, so when we did this compiling, we compiled it to this public JavaScript's dev.js.
Right.
So that was where we defined it in this output too, right?
Right.
So resources public JavaScript's dev.js. And it looks like this is what that built. So this Goog thing, this is referring to the Google Clojure compiler when it says this, right?
Right.
So this is Google Clojure compiler code. I don't understand what any of it means, but it looks like this add dependency.
-hello world /core.js.
Right. So check this out. So this gets into this output to output dir thing. Like I guess in this output directory, we have three things. We have CLJS. So I guess this is what ClojureScript core code looks like, right? It's some huge file. We have Goog, which is the Google Clojure compiler stuff. And then this is our actual thing that got copied over, this core.cljc. So this was that main file. And then this core.js is how it compiled that into the Google Clojure JavaScript code. Very rarely do I actually look at this compiled build
Yeah,
stuff. Though.
doesn't
You're
seem-
mostly just looking at the closure,
It
right?
doesn't really seem that helpful, right? Because like
Yeah.
even line 5 where like the meat is happening, right? Like cljs.core.println, like
So
I
that's the
still don't really
namespace,
know what
yeah.
that does, but I'm
Yeah.
sure like that's part of the Google Clojure compiler.
Yeah.
That like it's I'm sure if you dig down deep into some of those places, you would eventually probably see somewhere where it says like, you know, println basically is just console
Yeah,
log.
I guarantee you would.
Yeah.
I've never really explored it, like I
Right.
said. I like you for the most part. You're just sticking to this file. This is
Right.
what you're writing. This is what you're worrying about, and
Yeah.
this rest is just build configuration stuff that you have to set up. So anyway, we have this dev.js file, right?
So now we just need to make like an HTML file that like requires that, or
Yes,
basically.
that's exactly right.
Yeah.
So in this resources public, I believe we can just make an index.html, HTML, and I think we can serve this, and we should be all right. Let's do a head. Although from what I've learned from doing these is that
Yeah.
I can't do index.html file. CLJS target.
yeah, they're notoriously difficult and annoying.
Okay, so we have a CLJS target, which is where we're going to inject our ClojureScript code into, and then we're going to have footer JavaScripts. I guess this can be an ID also. And we're going to require 2 files, right? We're going to require, so this is ./JavaScripts / dev.js, right? That's our built ClojureScript.
Yep.
But we also need to require, because we're in dev mode, so I think when you're in production mode, it'll actually compile it down into one minify file that has everything. But when you're in dev mode, just to make the recompiles faster, like you actually need to require like the Google Clojure compiler thing, so it knows how to
So we
like.
probably need a bunch of these.
So this is ./JavaScripts
Yeah, that makes sense.
/ CLJS dev / goog / base.js, right?
Right, and it makes sense because when we looked in /JavaScripts / dev.js, our output,
It has that goog.require. Yeah, that's exactly right. Goog.add
Right, so it
dependence.
makes
So it
sense.
needs to know where goog is,
yeah,
right?
that makes sense.
Yeah. But when you compile the final output in production, it's just one thing that you need. You don't need
Right.
this Google code. But like the builds take a long time because it's doing all those optimizations. So this is a better way to develop. But yeah, no, this is right. So we need the base library. We need this dev.js, and then we need one final thing, which is to require the namespace that we want to actually run in the app. So by default, this dev.js file, this is just adding namespaces to the project. But we need to actually run a namespace. Like nothing's
Right,
going to
I
be
see what you're saying.
accessible, and like these are just things that are available should we want them.
It's just like you've defined a bunch of functions.
It's
So
basically
you
we
gotta,
just made a library, but
you
we still
gotta
like need
call
to
a bunch of
import the
functions.
library, right? So
or like call a function. Yeah.
yeah, so like the example would be like if you had an npm package JSON file, and you said like, okay, I'm gonna add Lodash, and then I'm gonna install the library.
Right.
Well, you still need to import Lodash into your project, right? So this would be the step that's like importing into your project, and this is just goog.require, and then the namespace. And this isn't a source. This is the actual
gonna say.
like
Okay.
source equals text / Java. Well, that's not. I don't even remember. I think if you just do script like this,
Yeah, I
this is
think
fine.
that's right.
So goog.require, and our namespace was hello world.core, right?
Yep.
We should actually just make a function to run. Like, so, okay, so let's just make one quick function. Defin
Print
hello world, right? Well, defin.
Yeah, tough.
All right, defin
Say hello.
alert message. Well, let's just say hello. Yeah, that's a good one. Say hello, right? And this will just print line hello. ...
Yeah.
I actually don't even know if print line is a thing you can do in JavaScript. Well, I guess I can show you this right now. Like,
Can you just do console log?
yeah. So in ClojureScript, you have. I didn't want to do anything that's ClojureScript specific yet. Like, I'll start with just print line. I think this will work. I think this will console log it. So if I just do say hello, print line hello, I believe that will console log it, right? So then all I need to do is require this namespace hello world.core.
Do you have to have that in in like double quotes? That code or not? I feel like you probably don't.
I don't know if you need it in double quotes or not, but basically this is JavaScript right here,
Yeah.
right?
Right.
Yeah.
I'm saying I don't know if you need the quotes. Maybe you do, but I don't think the browser's gonna like that.
Oh, you think I just do it like this?
Yeah.
Okay, cool. Yeah,
I
you
could
might
be
be
wrong,
right.
but can you
No, you
go
might be right.
look at your other example?
But this is written in Clojure, right?
Okay.
So, okay, I think you might be right though. Okay. So anyway, I believe that, so we're not actually calling this function, but then if I called it here, so we call say
Yes.
hello,
Right.
and then we recompile it. Now I believe if we run that file, it'll actually show that in the console. So we'll do our CLJS build once. Because I changed the Clojure, I need to recompile it down. And then let's run that index.html and let's see what we've got.
So so right there it says hello ... in
Oh.
So that's interesting.
It's probably that print line. Let's just do this the actual way that you would do this, right? Is like, so when you're writing a CLJC file, you have access to this function that's like pound ? And this basically makes like what you think of as like a switch or a case statement, where you basically give it the arguments of like what the host environment is. So like if your host environment is CLJ, I'll print line hello, right? ... But if the target is CLJS, which means you're running this on JavaScript host, you can js/console.log hello.
Can you just, like, to be clear, can you just make one of those say hello from in Clojure and hello in ClojureScript or something like that?
Hello from Clojure, hello from ClojureScript, right? And just say hello. So this js/console. I'll get back to that in a sec, what that does. But yeah, now I'm just curious what, like, when it's compiling this, if it's going to run hello from Clojure. Because I guess because we're calling it, like, when it reads this file, it might actually... Yeah, so it does say hello from Clojure, right? But if we ran this in JavaScript, it'd say hello from ClojureScript.
How do you run it in JavaScript? Like, what do you mean? You're saying if...
So we have that
go
JavaScript file, so let's just run it, yeah.
Okay.
So let's do Python-m simple HTTP server,
Right.
port 8080. And I believe if I go to localhost 8080, let me pin. Yeah, so we have resources, public, and then what's...
JavaScript?
It's just index.html, right?
It's JavaScript. Yeah, you're right, actually, that one. Oh.
But how do we... Yeah, so this is the
right
file, and if I go to console, goog.require...
Could not find hello world.core.
Oh, you know why? I think I have this in the wrong order. I think that you need this dev.js to be required first.
Okay.
Yeah. So now we have hello from ClojureScript.
Ooh, that's awesome.
So we need to break down so much shit just went
I feel like
down.
there's like a lot, big
But what just happened?
Gap there.
It is a really big deal, right?
That's
like
cool.
When I ran this line script, because like normally this is something that you don't normally have, by the way. Like you don't normally have just like a function just hanging here, chilling, like outside of the library, right? So when it compiled it, it actually ran that. And it was running that on the Clojure build system, so that's why it's running hello from
that's
Clojure.
weird. So you're saying when it compiles, it actually runs your code. It's not doesn't. Like,
Well, of course, but normally you don't have anything at the top level. You just define things, right? But I guess we will, because we're gonna have that, what you'd consider like React.render. That'll be at this top level.
Right, but I didn't think it would actually like evaluate the code. You know what I mean?
Yeah.
Like during compilation, it
Yeah,
actually
crazy.
evaluates it.
Yeah, crazy.
That is crazy.
Yeah, I guess it is but I mean, if you think about it, like from the Lisp syntax, it makes sense because, like, the defin is just defining a function, but it's running it still to get that function definition. This is like actually calling the function. So, but anyway, so this JS console log, right? So this word JS in Clojure, this is the JavaScript window object. In the JavaScript console, you have like window.console.log you could write, like something.
Well, yeah.
And this will log something, right? So this JS object represents the JavaScript window. Perfect. So if I do JS/, that's the same thing as calling window dot. So if you want to access something in JavaScript directly, you just do JS/.
Right.
Other than that, you can still call all your Clojure functions that you want. It's just you normally will do this for things like JS/document.querySelect or JS/console.log. Like not things that are like functions, but things that are actually interacting with the JavaScript API. So let's try something. Instead of doing this once, let's make this auto, right? Line CLJS build auto dev. And this will just watch for changes basically. So we can show an example. So it's waiting for dev.js. instead of js.console.log, let's do js/alert,
Yeah.
right? I'll save it. We'll see this automatically recompiled it.
Yep.
And now if I refresh the page, oh, because I'm not calling it, right? Say hello. Recompiled, and that was really fast. And now if I refresh, I get hello from ClojureScript, right?
Dang.
So that's a very, very basic kind of workflow.
That's crazy.
And we can run any Clojure code. So like, say I have some library that's like defin
Right. You can do anything here.
multiply numbers.
Right.
Numbers. This takes x and y. So I'll times x, y. Now I have a function. I'm gonna get rid of this.
Right, because we don't really need this CLJ like
Yeah, we don't need any of the
side
stuff.
of the branch. Okay.
But now it just says say hello would be like js/console.log, and like we'll do say hello multiply numbers 5, 10. So this should just console.log 50, right? And when I refresh it, I wonder. Oh my god, that's crazy. Because it doesn't have the con thing, right? I needed to leave that as CLJS.
Well,
right?
you also weren't calling say hello there again. You still didn't call it again.
But this needs that conditional reader whenever I use a JS. So if this was just a .cljs file, you don't need that.
When we had it just be print line,
because Clojure read that. ClojureScript wouldn't have.
If we just leave it as print line, will it work those? Is my question.
I don't know. Let's say
if you just do print line there, will it work in both Clojure and in JavaScript, or in Java and JavaScript?
I don't know if printline maps to console log. Maybe it does. Yeah, so it doesn't know what print function for evaluation environment.
Okay.
But anyway, if we made this CLJS, you can just use JS namespace. But I, for the most part, will literally write everything in CLJC files. So it's probably a good habit to get into, to do the CLJS conditional. And you only need to do this where you're natively dipping into JavaScript.
Right.
So like this multiply numbers, this times XY, this is the magic ClojureScript, is that I can just use the same syntax. It's only when you're accessing the API directly from Java or JavaScript that you need to say, hey, only in this host environment do this.
Did you say that if you had your file say core.cljs,
I could just do this without this reader conditional.
And then
so this will work, right?
But the
this
rest
gives
of
me
the
the
build process would work exactly the same.
Yeah, exactly.
Like you wouldn't have to change anything as long as you just change
so literally, let's do it. Like I rename this to CLJS.
Right.
I get rid of this reader conditional. I save. It built.
Yeah.
I refresh. Something gets logged.
Wow, that's awesome. Okay.
I change this to CLJC. This will break now. Because now it doesn't know when it's running it in the Clojure environment what to do about this JS /, right? So like this is broken.
CLJC.
Because it doesn't know what to do with the namespace JS. But, right? So like, yeah, this is the way that you normally do it. CLJ, print line, ... CLJS, console.log.
Oh man, yeah, it's kind of like a brain fuck. How there's CLJ, CLJC, and CLJS. Like there's all three of those.
Yeah, but really CLJC is the magic one because it's the superset that you can do.
Yeah.
So this gives me a ... on everything now. So really, if it's CLJ, we don't want to do anything. We just want...
Right, just that would be like an empty function.
Yep, so we can only say, only in CLJS, you print line, now it compiles, we still get something when we refresh. So
nice.
This is pretty solid, right?
That's really badass.
And then, so that's the native JavaScript. And again, we can access anything. So the key here is you can access anything. So pretty much, this is something to know with ClojureScript as well. Pretty much, ClojureScript is unusable with any language that's not React, any JavaScript framework that's not React. Like there are languages that wrap Ember bindings in ClojureScript. There are languages that wrap Angular bindings in ClojureScript. And they're like,
you're saying there's libraries.
There are libraries that do this, but they're like bastard children. Yeah. It's like so unnatural to use. Where like you're mixing disjointed paradigms.
Yeah.
But ClojureScript works really naturally with React's functional kind of like paradigm of UI state is encapsulated in one location. It gets passed as arguments into components that like know how to render themselves, and you compose them together.
Yeah,
and you use immutable data, and it may and then you have like this unidirectional data flow. And like pretty much it works so well with ClojureScript that if you're going to write ClojureScript, you're going to use React.
Yeah.
Like 100% guaranteed. That's the only way to do it.
Right.
So you can, like, one thing is this JS, right? This is just the window object. So if you have React or any JavaScript library as just a JavaScript library, you can access it from your ClojureScript code. So, I mean, we could show a simple example of that, but you get the point, right? Like, this JS is just the window object. So I could just do, if I say I had React, I could do js.react, for example, right?
Oh, yeah, you're right. Okay,
Yeah.
so all we have to do is like add like a script tag
Right, exactly.
that has like React from a
Right.
CDN.
But so you could do that. So I mean, we could show that real quick. Like maybe that's makes more conceptual sense. Where as the first thing I'd add is just like React. So let's just get it React from a CDN, right?
Yeah, just click CDN.
CDN.js, man.
Yeah.
This thing is dope.
It's classic.
No.
14.7.
No alphas. React DOM. Ooh. I don't think you need that for this.
I think you just need the one that you just copied.
Yeah.
That's so annoying that it does that.
Yeah, it literally has one job.
Right.
You have one job, CDN.js.
You need to add that. Like, it's so annoying.
Anyway, so we have React, right? And now in my ClojureScript code, I could console.log, right? Say hello. Instead of console.logging something, I can console.log like js/react, right?
Right.
I believe that'll work though. I mean, that
Yeah.
should do something, right? It shouldn't break. Yeah, so this is the React object,
Dude.
right? So you can access JavaScript libraries
Yeah,
right from
that's
ClojureScript.
dope, dude. That is amazing. That's gonna be it. Yeah, that's cool.
Right? So you could write JavaScript code like this, but again, like you wouldn't do this because none of this turmoil makes sense if you're just fucking writing JavaScript.
I mean, if
you're doing this for a reason.
But to be able to use React like that, that's huge. That's pretty badass.
Yeah, and like so, man, again, like I don't know, like because again, you don't write code this way, but if you did want to, right?
Yeah.
Like you could define a React component just as a Clojure function.
Right. But the point is, we did get React, like
right. So we just have React. You can do any JavaScript library. You can
Right.
have underscore or whatever. And again, like you don't need things like Lodash because you have ClojureScript. So ClojureScript like takes care of Lodash.
Right.
It takes care of a lot of Ajax stuff. Like it just takes care of a lot of stuff. But okay, so now we have React.
Yep.
There are libraries, right? This is a thing with ClojureScript. The way that JavaScript has a framework war, ClojureScript has a React binding war, right? There's multiple closures, like so. There's like a join between React and ClojureScript of like how you write ClojureScript so that it compiles to React. And there's basically 3 libraries that are kind of the kings right now, and they each have variants. So the first library is a library called Ohm.
Okay, I've heard of that one. From like
This is written by a guy named David Nolan. That is a total beast. He's just one of the coolest people that works in web development today.
I was gonna say David Nolan, but then I was like, isn't that the guy that did like Batman or something? That's Christopher Nolan.
That's Christopher
so
Nolan.
David Nolan.
Yeah, a lot of Nolans, but
Yeah, I saw David Nolan actually. At the React conference, and he was talking about and it was just like
right.
Like it was like
So
I was like,
yeah, but I feel that way whenever David Nolan
He
talks.
was like
This
too
is
smart. Like,
it's actually one of the problems with this library
Yeah.
is that it's a little too clever, right? It's like
yeah, like it has all this like these cursors and like all this like observable
so
stuff.
Ohm
Just, like, all this crazy
is
stuff, man.
Ohm is this crazy library that was the first one, I believe. I believe this was the first ClojureScript React binding.
Yeah.
And everyone was obsessed with it and everyone loved it, but it's like really fucking complicated. It makes you feel really stupid when you try to figure out how to use it.
There's just a lot of like real CS like stuff.
But just look at this shit like Rayify.
Right, like these
which is like what this is doing is it's like defining an abstract protocol for like a component and then like one-off using it, and it has this like weird namespacing on everything like dom/html /h1 and the state management. Apparently it's really smart, but it's one of those things that's like really hard to use and like don't use, like if you're watching the screencast, probably you shouldn't be using Ohm, right? Like anyway,
it's more of like an advanced tool.
Right. So now he's working on this thing called Ohm Next that bakes in Relay and GraphQL as first-class entities into the Ohm framework. Wow. So like this library is being called Ohm Next is like super bleeding edge.
Yeah.
And like again, it's like one of those things that's like really awesome that it exists, and I'm glad people are into it. But like, man, that shit just whooshes over my head.
Yep.
Even. So then there's this other one called Quiescence. Man, good luck with me spelling this.
Yeah.
Quiescent. Quiescent. I don't. A lightweight ClojureScript abstraction of React.js.
Okay.
Yes, this is one. It's called Quiescent, right? This is a simpler language than Ohm. Yeah, like this talks about all the problems with Ohm and like it's so complicated. But anyway, this one's a little bit less used. This is a little hipster. Like I really don't know anyone that uses this library. I just know that it exists and I've seen talks about it.
Right.
Then the one that's like the sweet spot, if you're doing like Goldilocks style, like one was too hot, one was too cold, and one is just right, is this library called Reagent, which is, I am convinced, the single best UI library ever created, and nobody knows about it.
Better than React.
Well, I mean, it is better than React because it's React Plus. You know, it's
right.
like it's React Plus stuff, right? Yeah. So I mean, it's implicit that like React is obviously amazing, but this is a better way to write React, right? So this actually legitimately is one of the best kept secrets in web development. Is this library called Reagent? And there's like a cutting edge framework on top of Reagent called Reframe that basically gives you a lot of Flux-like stuff built in. So that's like kind of the ClojureScript wraparound Flux is this thing called Reframe.
Okay.
But if you're just looking for the wraparound React, is this library called Reagent. So if you take nothing else away from this, it's like if I want to write ClojureScript on the web, I will use React and Reagent. Yeah. Like that was a long-winded way to get to that point.
Yeah, like the last like 30 minutes have been building to that. Like
we're gonna use Reagent.
All right.
So anyway, that gets me back to my project CLJ. So Reagent is a ClojureScript library. I included it here, right? It's a ClojureScript library. So we have Reagent, we can require its namespace, right? So in this core.clj, all we need to do is require reagent.core as reagent, I believe. And we need to refer. So you know what that does?
No.
Well, actually, no, this is fine. We don't even need to refer this. We can just leave it like this.
I don't know what refer Adam does. But...
So refer, so when we require a namespace in Clojure, like require reagent.core as reagent, that's just saying I want to import this namespace and I'll access it through the name reagent.
Yep.
But if I do refer, that basically says, hey, take this function that library defines and give me access to that function without even namespacing it, just in my local namespace.
Oh,
so if reagent has a function called Atom, which it does.
So like later on down below. Like
right. So Atom is a Clojure function, right, that makes a mutable container around an immutable object, right? Atom is how you deal with stateful things that you need to change, right? Because it's a mutable container. But reagent defines its own definition of Atom. That's the key to how it works.
Okay.
So if I referred Atom, that means whenever I call Atom, I'm using a reagent Atom as opposed to the normal definition of Atom. But we can just do reagent/Atom. I think that'll be a little bit cleaner. Yeah. Like it'll be more, I guess, obvious
People
to what it's doing.
Understand what's going on.
Yeah. So /reagent. And again, this works. There's no errors. I believe there's no errors. I hope there's no errors. It doesn't look like there's any errors. So we'll change this to CLJS in a sec because we're definitely gonna want to. But all right, anyway, this worked though, right? Like we have access to reagent now.
Dang, I think it's super slow.
What?
That Clojure compiler.
No, it's pretty fast.
Is it?
Like if I change something here, like instead of XY, I just square the X and hit save. Compiling done. Like less than a second, right?
Okay, sweet.
Okay, so we have our reagent library. And let's change this to CLJS and just for simplicity because...
So we don't have to keep writing those like switch statements?
Yeah, it is kind of like, because like CLJC is like one of the greatest things ever made.
Yeah.
So like, I just like want to push it at any given time, like even if it's not perfect, but anyway. Yeah. We'll make say hello call multiply numbers on 5 times 10, and then we'll say hello, right? And because it's CLJS, this will just compile normally, and then here, we'll console log it.
Nice.
Refresh, and 25. Okay.
Which is actually 5 squared.
Right, which is 5 squared.
Yeah.
Okay. So, the idea of reagent is that you will define a React component not using any syntax other than writing it as a function in ClojureScript.
Yep.
Right? This is the big idea. So let's get rid of all this boilerplate and let's set up our own boilerplate. So let's just make an app component, right? Def an app.
Yep. Nice.
And this is one of the coolest things and like very ClojureScript paradigm and gets into like as we start going, you'll start seeing all the differences that make this like actually fundamentally different than writing JavaScript code. But the first difference is that you write your HTML not using JSX, but using a syntax called Hiccup, which is a library that converts Clojure data structures to HTML. So if you think of HTML, right, this is an XML document, right?
Absolutely, yeah.
But we know XML is just a tree structure.
Yep.
This can be represented in a data structure that's more native of a format to a programming language. We see this all the time when you make a JSON API for an HTML document,
Yep.
right? So you can define HTML using an array where the first argument is the tag name, and the second argument is a key value pair of all the attributes on that tag,
Gotcha.
and the third argument is the inner of that tag.
Yeah.
So that's the content of the tag, which could be another tag or it could be text.
Right.
So in this example, we would have an H1 tag.
With a class on it or something.
We could do class
Right.
title,
Yep.
and then some text that says hello from like a Clojure data structure,
Right.
not JSX. Wow. Right? And we need to do exactly that same thing that's like that
Yeah.
render, right? So I believe this is just reagent/render app, and then it's js/document.query selector CLJS target. So that's exactly the way that React would be,
Oh,
right?
God, that's
And I
great.
refresh it. Hello from Clojure.
That's badass. Dude.
So this is an H1 tag, right? But instead of using JSX, this is just a data structure, which means we can manipulate it the exact same way you'd manipulate any other data structure.
Mm-hmm.
So say, for example, this was a div, right? And inside of it, we wanted to do some sort of a loop, right? Like for I in range 10, which is like from the numbers 1 to 10.
Yeah.
Let's just do an H1 with I, right?
This is going to turn into a FizzBuzz coding interview.
God damn it. It might. We're going to need to get Emacs soon.
Oh,
but anyway, we have an H1 to 9, right?
Yeah.
But what is really important
that
to
was
know,
cool.
what's really important to know is that there's no templating language. I'm not using Jade. I'm not using JSX.
Yeah, this is just
Right?
Clojure.
When you asked me what the difference was between like JSX and like the way you do in JavaScript, the difference is that JSX is a templating language, right? Like there is no abstraction or differentiation between a templating language, a data structure, a function, anything. It's all just data structures.
Right.
Like Clojure is a language written in its own data structures. Like this function is written as a Clojure list, which is a data structure. This is like one of the things in Clojure that like people like go crazy over, right?
Like the code is the data.
Yeah,
I
data
always
is
hear
code,
that.
code's data.
I feel like it's just like one of those like high phrases, like the code is the data, and the
Yeah.
data is the code. Like
You do need to be
that's
a
how I
bit-
feel. Like I don't,
You're not so far off. Like
that's
it
how
is
I
kind
feel
of a
about it. It's
stoner
like,
thing.
Yeah, dude, whatever. Like
Code is data, data is code.
Yeah.
I think it's probably code is data is the wrong way to say it. The
Yeah.
better way to say it is data is code.
Okay.
Like I feel like that actually like makes more conceptual sense. But anyway, the thing that's important is that it's not a different library. It's not a different paradigm. It's all one thing. There's not like in JavaScript, like when you write React, you're constantly doing this kind of thing. Where it's like I have some tag and then I make this, and in here I can magically write JavaScript, right?
yeah, and then you have to, it's like context switching going back and forth.
Yeah,
Sure.
it's like there's no concept of these magical curly braces in ClojureScript. There's no place where your code works and it doesn't. It just always works. It's always
Right.
Clojure, right? There's none of that. So that's really cool.
I get what you're saying. I just feel like JSX hit it on the head so hard and so well that like it doesn't feel like a problem to me. I don't know. Maybe it is, but
I mean, it's not a problem, but it's a thing to learn.
Yeah.
Like JSX works a certain way. It has certain words that work,
yeah,
certain
it
words
does have
that
its
don't.
own like idiosyncrasy.
They have these things with like the this.props.children,
Yeah.
right? And then you have things like class names. Like you have these different things. Whereas there's nothing to learn. Like if you know a data structure is, you can build UI
I mean, you
code.
still need to know like the semantics of like HTML and
Yeah.
some stuff like that.
That's
So,
pretty much it.
But yeah,
Like HTML is XML, you just build it in ClojureScript and it's going to render as XML. You know, like I don't know. I find this much easier conceptually to work with. And there's less to learn. It's like simpler.
yeah,
Like not like you have to know Clojure, but it's simpler like once you do, you know. So anyway, this is a div, and then we put like an h1 in here, and you can do some logic in this, right? Like class, like should this have the class active? I don't know. Like if greater than 5, you know, 3. Like if 5 is greater than 3, which it is, add the class active, or else don't. So like again, this is just Clojure writing conditional logic. So this should render with the class active, right? Some text, and then if I look at this, has class active, right? But if I change this to 13, nice. No class active, right?
Right.
And again, there's no templating language or anything. It's just writing data structure. So this is really cool. I find, I guess if this is a new concept, it might seem really weird, and you might be like writing UI code in Clojure, like with Clojure data structures. That's bizarre. But like I assure you, it works really well. Okay. So, whatever. We've made a better way to write HTML. That's not basically that impressive. Yeah. It gets impressive when you add state into the mix, right? Sure. This is kind of the key thing. So let's just define, let's call this def app state, right? App state. And we're going to give it a map of key value pairs, right? And actually, I'm going to define this as an atom because we're going to change it, right? And I told you before that Reagent defines its own kind of atom, which for all intents and purposes works exactly the same as a Clojure atom does. And again, an atom is just a mutable container around immutable data structures. So like basically it's like a box, and the box has some stuff in it. And you can never change a Clojure data structure, but you can change what's in the box. So you can basically be like, yo, put something else in that box. So it lets you put different things.
So like where you have class if greater than 5, 13, you could instead of 13, you could use some piece of state and like change that dynamic.
Yeah, exactly. So instead of like, let's just do this for the text, right? Let's put a message in here. Message hello from app state, right? And instead of the text, so the way that you access a data structure in Atom is you dereference it, which is what you do with this @ sign. So I do @app state, that dereferences the Atom's the box. Putting the app sign in front of it is like the content of the box. So this will actually be this data structure, right? But again, we can change what data structure's in that box.
So you need to get the message out of
exactly. So I would call message on app state like that, right? And then this should say hello from app state when we refresh it, right? And line 4.
Yeah, we need
parens. Yeah. We might need to switch to Emacs. hello from app state, right?
Yeah, awesome. So
but
you could
the reason why this is the reagent atom and not a normal atom is because it has one distinct feature.
This is like Flux, isn't it?
Yes.
Okay.
Which is anywhere that atom is dereferenced automatically adds a binding to that data structure, that whenever that data structure changes, it will automatically inject the new value of that data structure into the component.
Yeah, so like I think we
and
talked
to all
about
of its
this once
children
before, but like to me, that's what Redux is, basically. Like that's like the main thing that Redux does.
Well, I don't think this is Redux. I think this is React. Still.
No, because like
right,
the idea of having like being able to subscribe to a data source and like get updates from it and like change yourself based on that like new information. Well, that's the same thing. So like in Redux, you have the store, and then it just like people can like hook up to it and like listen to it. And that's like the same thing as this. Like you have your app state, and then on like line 10, you can just like hook in and be like, okay, I'm interested in it.
But isn't this just? I get what you're saying, but like in React, if you have like this .state.x, like it just automatically has that subscription built in. That whenever it changes,
the app state that you just defined right there on line 4 is
outside the component. That's why it's a big thing. That's what Redux is.
It's outside of
gotcha.
React component.
Okay, so then you're right. Then this is in the Redux style of the state lives outside the context of the component. Right. You can have state local to a component in Reagent in this workflow too, but
like, can you define like a get initial state kind of thing?
Yep.
And like,
exactly. So basically, what this syntax is, where I wrote a function that just returns a thing, that's the same thing as just doing like a map that has render like this,
Gotcha,
right?
gotcha.
Like that's just a
You
shorthand.
can use the React lifecycle
Yeah.
names.
You can use exact React lifecycle thing. It's like this is just a shorthand for doing it. Okay, so we're in Emacs now. This is gonna go a lot a lot smoother.
Yeah.
All right, yeah. If you're back, we're in Emacs now. So anyway, div some text from Emacs. Yeah, right.
Sweet.
Okay.
So yeah.
So now we have a message in our app state, and I want to show you how this works. So instead of this some text from Emacs, we'll dereference the message at app state, and we'll call message on it.
Right.
And we're gonna put a JS/set timeout that will run a function that swaps the app state assoc in message new message, right? And we'll run it after 2 seconds, right? So if I
Nice.
save it, run this some text from Emacs, hello from app state, new message, right?
Dope.
And what this is saying is that I'm just changing the state, right? The swap app state, just this is the Clojure syntax for actually updating the state. So I swap app state,
Yep.
send message with a new message. And because this is a reagent atom, it subscribes to the change automatically, and then it knows to re-update, right?
Right, because you used the reagent atom, whenever you dereference something off of it.
Yeah.
That got
So check this out. So now, say I want to make a component. So like I want to abstract this message into like a header component, right? So I do defin header, no argument. It'll take an argument of message, for example, right? And this just renders a div, and then in h1, class title.
Is it just implicit
Message.
Is it implicit returns in Clojure, or do you have to like tell it?
Yes,
to like,
the
return?
last argument's returned. So class title message, right?
Gotcha.
Now, so say I make a class container
Yeah.
like thing. If I want to render this component, again, it's still just Clojure data structure.
Yeah.
It's header, and then I'll pass in the message. So message at app state, save it, and this will still work. Hello from app state.
I think we got rid of the function that.
Yeah, but this is an H1 class title, right?
Yeah.
So I took a section of this app and I abstracted it out into its own function.
Yeah, totally.
That now renders that down, which is really cool. Because this is like really like you can basically like play around with making these things really, really reusable. So say I have this hello world core.cljs. Now I want to do like some abstracted component. So let me say I have a title component, title.cljs, right? And in this hello.world.title is where I define this defin header that takes a message as an argument, returns this component, h1 class title message, save that. Then in here, I can just require out any functions I want from this namespace. So
Nice.
hello world dot title refer header. Now, even if this isn't defined here, I can still just call this header component, even though this is in a different. It's on a different file. Still works, right?
Do you ever have namespace collisions like where somebody else wanted to use the namespace hello world? Like,
No, you very rarely, because normally the first word is the name of the library on Clojars, which is like the npm.js kind of thing.
Yeah.
So like you just use that as the first thing. The dot core is pretty standard for like the top level API, and then you'll normally namespace it when you refer it into your program like
Yeah,
your
you'll
thing
pick
too.
your own name for it.
But this is just like a name of a component. So really, like this is just it's just a function, right? This makes these pieces of code really reusable.
Totally.
And it's a function that works in Clojure on your back end also, if it's a CLJC file. So like you really have these little snippets of code that are just really easy to import around.
Are you talking about like that? Are you talking about that in terms like because you're thinking about like server rendering, or
Well, I just think of things like
why do you care that that's available on the server?
well, for pieces of UI code you wouldn't, but
Okay.
for just any generic function like a library, like say like for example the thing that I was showing you a bit earlier, where I made a visualization that can take an arbitrary file and visualize a neural network for how you would compute that data source, right? So like I give it a file that has it's a closure data structure, right? And it's an array of arrays, and it's an array of 3 items, right?
Yep.
So you might want 3 input nodes in that data structure. So you need some function that knows how to convert a neural network from like an arbitrary data structure.
Yeah.
But like that you might want to do on the back end because you might want to run it on Java, but you might want to visualize it on JavaScript. So whatever function that is, you'd want to share between both.
Totally.
Or like any kind of algorithm you'd probably want to share.
It's definitely nice to be able to just like
Yeah.
share code across like client server. Like,
Right, exactly.
I have that problem all the time because like we have like a Go backend and a JavaScript, client, and it's just like sometimes there's logic, in one place that you really wish you had in both.
Yeah, exactly. So you probably have to write the same things a lot over and over.
Yeah.
So this is really cool. Let's step it up one notch. Let's do div class equals items list. And let's render out a list of items. So we have our message here. I mean, we can keep the message header message, or this was message on the dereference state. And then we can do a list, so class items list for item in items at app state, div class item p display item, and this will be a data structure that says items vector display item 1, and then
display.
it's just a key.
Gotcha.
This could just be text, but normally instead of using text, I'll make everything hash maps and just with a thing that says display. That's pretty general with the way I write all my code, so that I know if I call like display on anything, I can get some human readable form from it. But anyway, if I save this and rerun it, I have 1, 2, 3, 4, 5, right?
Nice.
So this is how you do a list. We could abstract this component out into items list.
Totally.
Give it the items as an argument. Items list here. This then, instead of here, will take items, and then it takes items as an argument. So basically, it's just a function, and the top level API is very strictly defined as arguments to that function. So, like with a React component, the API of the component, you need to do something like prop types to like be able to say it. But here you can kind of like any way you'd normally test any function, or any way you'd normally validate the arguments of any function, you can do for your UI components also, because they're just functions.
In that like items list component that you've defined right there, can you put like initial state and render and stuff?
Yeah.
Those actual like, I don't know. I guess that part's kind of confusing to me. Like, can you use the whole like React lifecycle like functions inside of your items list?
You can.
Okay.
But again, like, I feel like for the most part you don't need to.
Okay.
The only time you like, if you have some sort of local state, like for example, we can make a component called like counter, right? And this could have some sort of local state. So like if we made this current count like just a def here,
Right.
so maybe they don't let you define it in a component. Like if I did it just like this, right? Yeah, that seems to work.
Interesting.
Yeah, it's weird. So I guess the idea is that, well, I guess that's like reagent. I mean, like Flux, right? Like you want to have the state outside the component and inject it in. But anyway, so that was much ado about nothing. Right. It seems like it. So anyway, we have this header items list, right? So this is where we were here. You need to do the key also. Like this is like this is a React thing, right?
Of course.
So that gets rid of that annoying console warning, I believe. Yeah, so that's finally gone.
Nice.
So anyway, so where it gets really nice is when you can do this kind of stuff, where it's like, okay, class item. I want it to be active if it's the active item, and we'll have a part in our state that says active item, right? Active item, and it's none of them are active yet. So the class is item, but it should be active it is. So we can do some like if statement here, like if equals, so we'll take items and we'll take the active item. Then we'll say if is equal active item, we'll do item active, or else we'll just do item.
Will they actually be equal? Like,
well, in this case, I'm gonna just set the item to active item when I click on it,
Okay.
just for show.
Right.
But anyway, this is just like interpolated right in the code like that, right? Like class if equals active item item.
Yeah,
item
it's nice. That looks nice. I like that.
And then on click, because we have this P, on click, swap, app state, associate, active item, right? And then we're not doing anything with this dot active right now, but if I go to my index.html that I had,
Oh, nice, yeah.
which I think is resources, public, index.html, we can just do some like really, really simple CSS, just like
yeah, and like
where it's just like
normally you just use like your less or Sass compiler and have it compile into
yeah, exactly. And actually Clojure, like Figwheel does that for you when I show it to you, like Figwheel will do it, but like sorry, I'm all over the place here. This would be dot active, like dot item dot active would be like this.
Indeed.
And then in here we'd have background color, not like this, and we'll just say yellow. Well, that's gonna be hard to say. We'll do coral. So that's just some basic CSS.
I don't think you need the quotes around there, around coral.
And you might be right. Okay.
Expect it on click to be a function.
Right. Sorry.
Cool.
And now when I click on one of these,
Interesting.
wait, hold on, click sauce. Oh, I'm not passing it the active item, right? So here I need to pass it active item, so it gets that second arg.
Totally.
But now when I do this,
That's
right,
awesome.
as I click on something, it's coral. And it's really interesting to kind of break this down a little bit. Just when you really think about like how little code this is, where I have some sort of stateful component. Basically, all that I'm doing is when I click on it, I change the state and I render it in the display, and it's like really, really condensed down like that.
Yeah.
And then if like you wanted to add a new item, you could add a button on the bottom, click new item, right?
Yep.
So anyway, what I wanted to show you.
To do MVC action.
What's up?
We could do a little to do MVC. Action.
Yeah, exactly. And actually, I don't know if there's a to-do MVC implementation for Reagent, but it is. That's not a bad idea. But
yeah, we should do that and open source it. That'd be sweet.
yeah, and like. So now where this like the magic really starts to happen is when you get into like you know doing like more like code-based things. So like say I just want the even numbers, right? Like I only want even items to show up like with even numbers. Well, this is really easy. Just basically for items instead of items, I can just filter, you know, filter even item.
Totally.
Right. Well, if it's just I don't know if how you filter indexed, but like
right.
Actually don't even know how to do it. But if this had like a thing that was just like, you know, like index 0 or index 1. And actually
regular expression against
no, you could do it like this kind of map indexed vector items and then filter
or something.
Function even first. This is now a vector, right? This is index item. This is something like that. Right?
Nice, gotcha.
But sorry, but anyway, like doing this kind of destructuring, like, and this is actually the exact opposite because we don't have a 0. But if I did, but if I did ink, right, like first, like ink, if I ink this,
right,
then that'll work.
Or you can just change it
where it's like item 2 and 4. But anyway, like that kind of filtering is just there's no libraries, there's no anything. It's just the syntax, and like you condense it down. And now the thing that makes this really interesting now is that I normally don't ever update your app state directly. You normally update it indirectly, right? That's the whole idea of Flux, is that I want to indirectly update state. I don't want to touch it directly. I want some sort of abstraction that lets me run filters and events and event handlers and like logic and, you know?
Right, totally.
Like you decouple it out. So there's a library in Clojure called cljs core.async. Clojure core async, right? And this is a library that lets you do asynchronous programming in Clojure, but you can use it in ClojureScript also. And the idea is that it gives you this abstraction called a channel, which is essentially a persistent queue in memory. And it lets you put arbitrary events on that. It lets you have arbitrary listeners on that, and allows you to act as if you have multiple threads going on in your program simultaneously, even though you don't.
Yeah,
so
it's like the JS event loop or something.
Yeah. So this goes in the project CLJ. Goes here, right? And whatever, this is just whatever was in my library, but I'm sure they're on a different version now. But and I might need to restart this. But anyway, now I can require it from here. I can require cljs.core.async refer chan and put. And I believe I need this guy also. You don't refer like
Gotcha.
this. You refer like...
For macros, require macros.
Yeah, because I guess... I don't know. So you need to have a require block and a require macros block. So anyway, goes up here, but you refer it in. So anyway, channel, right? Which is a persistent queue in memory. And you want to be able to have a consumer that reads off that queue on an infinite loop. But the way that that syntax works is like when I had like... So say I had def event channel, right? And this is a chan. That's a core async channel, right? Which is just like having like a queue, like a Redis queue or something just in memory of your app, right? And I wanted a consumer that reads off that. I could write a Go block and then do a while true. Let message equals take off that channel, right? Or event channel.
Right, so that's going to be like the...
Is that if I had this outside the Go block, this would crash the process, right? Because it still would be an infinite loop.
Yep.
But here it's an infinite loop. And this take off the channel, what that's saying is that I want to take off the channel and do something with the message, but I'm going to block myself until there's I'm going to park, right? That's what it's called. It's called parking.
It doesn't do anything until there's new
Yeah. Exactly. And this would block the thread if it was outside of the Go loop, but because it's inside the Go loop, that parking isn't going to park the thread that the main application's running on. So like I could then just js/console.log message, right? Now, and I'll PR string it because that'll put it into like a readable format. But anyway, this will run fine, just nothing will happen. But if instead, when I clicked on one of the items, instead of making it active, I mean, I could make it active and also do something else. I will put, right, onto event channel some key, some value, right?
Boom.
And now when I click on one of these,
Nice.
not only does the item become active,
Right.
but
You can actually...
that message gets put onto the channel,
Right.
and that consumer right here is reading off of it, right?
It's so funny, dude. This is exactly what Flux is. Like, it's just makes me laugh.
Yeah, but
you, like...
look at the overhead. I mean, like, I'm stumbling.
the same thing.
I clearly suck at it, but
Yeah.
but look at the overhead, though. This is the key. What overhead is there?
It's the same thing as Flux, though. Like, it's exactly the same. That's what Flux is. You put like a message onto a dispatcher that a store listens to, and then updates its state, and then components listen to the state and update themselves. Yeah. So it's literally exactly the same. That is Flux.
So anyway, so I have this let message on channel. Now, this is where it gets interesting. I can make a events. Say, like, this is the simplest thing, is I have this hash called events or something, right? And let me give an event like update active item, right? Function.
Yes. So this is
active item.
This is like a reducer, a Redux reducer.
Sure. Okay.
I'm sorry. I'm just trying to like.
No.
I just like.
I don't know
like,
Redux well enough to know.
Take these
but,
concepts and like reframe them in like the thing that I know.
So what this is saying is, like, I'm going to take all the arguments are going to be a hash map. This is just Clojure destructuring. This is a key called active item, and I'm going to swap onto app state. Well, this should probably be at the top then. I'm going to swap into app state. Exactly what we're doing. Assoc in active item, right? Get rid of this filter so we have more of these guys. Item in items. Maybe this is a little too big. Maybe I should make it a little bit smaller. So update active item. This is like now in this global events object, right? So now all I'm going to do is, instead of accessing the state directly, all I'm going to do is put an event onto the event channel called update active item, right? So now I'm putting a vector onto that event channel, and my consumer will read off, like, let event, comma, event data, like event name, event data, read off the event channel. And when you get it, look in that global events hash and call the function, right? So it's like call event name events with the data that got passed in, right?
Yep.
Like, so now that consumer will run that, and I believe this will still work. When I click item 1, it's active, item 3, it's active, item 4, it's active, item 5, it's active, right? But now this event is abstracted out of the component, right? This component just knows how to put events onto some sort of event stream. So if I wanted to take this component and make it truly reusable, I would inject the event channel into the component, right? And then when I call this items list, I'll give it the event channel. Now this guy can live outside the context here. We'll put it in the hello world.title namespace, this def items list function, right? So now in the hello world.title namespace, let's also import header and items list. Yeah. Item 3, item 4. Oh, because this hello world title will need the put from Clojure core async, right? Because it's, but anyway, require cljs.core.async refer put, right? So now, still working, right?
Pretty awesome.
But I mean, really look at what we have here. This is a completely reusable function in Clojure and ClojureScript.
Yep.
That just takes an event channel as some input. It takes the state that it dereferences. And this function is completely isolated. It's like, I'm just going to take in arguments of this arbitrary event thing, this event queue, and then state that I need. I know how to render it, and I know how, when there's some sort of UI interaction against me, to put an event on that channel.
Totally.
But it really doesn't care what the actual layout is. And then here, we're basically saying that event channel is just this core async queue that I'm just like, have some sort of consumer that loops through and reads, right? And this just is updating this thing that's called like globally like app state. But really, I will write like whole libraries of these functions that are reusable across all my apps that just take like event queues and event channels and the state that they need. So that's really cool. All right, I want to show you Figwheel now, because I think Figwheel is the last thing that like ties the whole package together. But again, you got to figure out how to set it up. It's always the hardest part, figuring out how to set things up. But like, again, like look at this. This is, you know, like, this is a fairly non-trivial thing. Code, that's like, this is all our code that we have to make this entire app. And like, you can make these like insanely more complicated. Like, anyway, so I want to show you.
Literally do a to-do MVC, like, it wouldn't be that hard.
Yeah, exactly. Like, I don't think it's that hard at all.
Right.
So let's do Figwheel. So Figwheel. Okay. So we need to include it in our project CLJ. We need to put this line Figwheel plugin thingy here, right? This line Figwheel plugin.
Yep.
And then this Figwheel true in our CLJS build, right? If that's all you need to do, we are the luckiest people on the face of the fucking planet. But I have a feeling it's not that complicated.
How will you know if it worked?
Well, we'll see. So instead of running that line CLJS build auto, we're gonna use Figwheel as our big tool by doing line Figwheel.
Okay.
Right.
And is that going to shell out to CLJS build or whatever? Like how
it will build your ClojureScript for you.
Yeah.
But it does that among other things. But basically what Figwheel will do is it will be able to know about the state of your application. And okay, so it says this Figwheel server, it's compiling our dev.js. It did that. It's launching ClojureScript REPL for dev. Prompt will show when Figwheel connects to your application. So it compiled our ClojureScript. Let's see if it can connect to our application. Which I believe there's some configuration you need to do. Yes. Oh, yeah. So it looks like it did.
It totally worked. So at the bottom it says...
Yeah, so actually, Yeah, so it says prompt will show. So it looks like there's a prompt,
Go
right?
back to your
So by the way, this is a ClojureScript thing. So I can do +1. This is a ClojureScript REPL, right? So +1, 2, 3. But it's a ClojureScript REPL that, yeah, look, it did work. So that's all you needed to do.
Figwheel trying to open.
Yeah, it worked.
Yeah.
Sign connection established.
That's dope. So now
Yo,
if you go,
I don't know why I thought there was so much more configuration
so
for
now
it.
if you just go change coral to like sky blue or whatever.
Right.
Don't
So,
change-
so before that,
Wait.
check this out.
Click one of them, so it's coral.
No, but check this out though. Just if I do this.
Do you have
So
to
I
get
don't
it
know
from-
if it's in
You have to
my.
get it from a namespace. Do you have to do hello world?
Oh, you're right. Require. You're right. So require hello world dot core or as HW, right? Okay. So yeah, sorry. The REPL, like you never normally use the REPL from this little thing, but anyway, I have HW/app state, right?
Nice.
It knows about my app state, so I can actually inspect my current app state by doing something like this. And guess what? I could set it also. So like this is a REPL into your UI state. Here, maybe it's
That's
easier to
insane.
see it
That's so
like
crazy.
this. So if I did like swap HW/app state, assoc in message new message,
Oh my god.
right?
That
Like
is
that's
crazy.
actually changing my UI live. So what Figwheel does is, and again, like I could
There's like WebSockets connecting to your browser.
yeah, it's exactly that. And like I can debug my app state like this. But again, like I said, you wouldn't normally just do that. You normally, the way that you do
That's
this is
fucking-
you
that's
do
like
it directly
so-
from your code, right?
So fucking mind blowing.
So I have my UI over here. I have my code over here. So ClojureScript, hello world, source, hello world, core.cljs, right? I'm going to change this from instead of def to def once, which is, it's just some Clojure thing, which means like don't change, like if you reload this namespace, don't change the value of that. Like, I don't know. Figwheel just needs
It's like
that.
some kind of caching mechanism.
Yeah, it's something like that, but it needs that to be def once for it to work properly. But anyway,
No, that makes perfect sense. Like it's saying,
So
don't redefine this when you come back online.
yeah, so I wanted to bring the title JS thing over here, but I don't like that this is message. Like yeah, let's change this way this works to like a p tag instead of an h1, right? And
Sure.
but it won't do it unless I change the top level thing. But now I changed. It'll only work if you change. This doesn't reload if you do a sub namespace. You have to do it in the actual namespace.
Weird.
But say I just define the header component here. Maybe this will be easier to show, right? I define the header component here, and then I don't refer header from hello world.title.
And then wherever you were.
Yeah, so
Oh, yeah, no, you don't need
so anyway, but now I'm like, I don't know, should this be a p tag? Should it be an h1? I can just change that to h1 and hit save, and it just injects the changes into here, right? So now I basically have, like, I can just go to town here, like h2. But notice it's not changing the state. This is
Right. Like,
what
click-
gets crazy.
Dude,
So
this
like
is the crazy thing.
so,
Click
like-
on one of these. Click on one of the items and turn it to coral.
item 4.
Yeah, and then go change it to sky blue or something like that. That would blow my mind.
Well, we'd have to change in the index HTML because we don't have SCSS. But if we did,
Gotcha.
no. But let's add some SCSS, right? Like,
Or you could just add a different class, I suppose.
oh, okay, I like that. Yeah, no. Well, we can do it right here if you really wanted to, right? Like, we could put a style tag. You can put a style tag anywhere, right? But the way that this would normally work is you'd have, I mean, we might as well just show you it, right? You'd have some file like hello world. Let's just call it styles.scss, right? Well, actually, let me just do CSS. We don't need to worry about SCSS right now. So we'll call it styles.css. And we'll do dot item dot active background color coral, and let me just delete the other folder and make sure that's still the other thing and make sure that still works. So that was in the index.html, right?
Yes, it was.
All right, so this is resources public index. Yeah, let's just get rid of this. Oh, we need the link tag though,
Yeah, I
right?
was gonna say you'll have to like bring that in somehow.
Oh my god. dot slash. Like, I don't even remember how to do this. Rel equals.
Type equals. Or is it type? Oh yeah, rel. I don't think any of that. Oh,
Yeah.
is that really what it was? Oh
Yeah.
my god.
Oh my god. But rel equals style sheet, right? Href equals this. But anyway, so now, so check this out. I do resources, public, style sheets, styles, background color, sky blue. Save. Oh, you know what? But it would know about this, I think, if then
I have to tell Figwheel somehow about
Yeah, but if I reloaded... What's up?
I bet you have to tell Figwheel where your CSS is. Like, how
Yes,
would it know?
you're
How
right.
would it know?
You're right.
Yeah.
That's exactly right. But if I... Okay, so good call. So
Klij.
project.klij. I do Figwheel, CSS dirs. This is resources, public, style sheets. Now it'll watch that. I think I probably need to reset line Figwheel. But now it watches that. And any time I change the style sheets, it'll inject it in with the app state still in the same place. It's fucking dope.
That is dope.
Yeah.
Insane. I don't even know how that's possible. I guess it just like rewrites like the link tags.
Anyway, let's load it up. Have it connect. I may need to restart it a couple times when it first starts. All right, cool. We're connected, right?
Mm-hmm.
So item 3, item 2, item 4, item 3. Background color sky blue. Save. Yeah.
That's amazing. That part's really
State is maintained.
Figwheel. Yeah, that's really amazing.
State is maintained. If I swap, so if I do like a little on click here, on click function event, you know, swap. Let's swap it directly, but swap app state, assoc in message, new message, right? Click new message. Let's go here. Let's do dot title.
Yeah.
Background color, I don't know, orange, new message.
Orange is so boring, dude.
Oh, but dude, if I swap this to new message, I want it to be another new message, right? Another new message, save that, click it. Yeah. Like, that's how you fucking build UIs.
That's pretty sweet, yeah.
That's how you fucking
nice,
build
That's a
UIs.
nice, for sure. Definitely a nice workflow.
Yeah, and it's like, people don't realize, like, with Flexbox and Figwheel and writing it in Clojure, where, like, again, these are condensed down anyway because we have these templates that are, like, looking like HTML.
Yep.
It's like you can build some UIs like, pretty fucking
that
fast.
is pretty sweet. I do like
And because, like, your components are so reusable, I have components built for, like, pretty much everything already. Like,
yeah, the Figwheel thing's amazing. It's like, it's pretty sweet. It's like a WYSIWYG. You just like change in like your little like tiny stuff, and it's like.
and dude, this Clojure, like writing, and like
stateful,
you can
amazing.
loop over things, and like you have all of Clojure to play with. So you can do algorithms, like you said, you can import things in those CLJC files. So you can import algorithms or other people's libraries, and yeah, man, like building UIs this way is fucking phenomenal. This probably was not even the best use case for it, but like at some point we'll have to jam on like actually doing some machine learning stuff this way, like with a visualization attached to it. But
That'd be tight.
yeah, dude, I like showing the Figwheel because that wraps it up.